So how are you finding the Berlin Summit so far? I hope it's good. Thank you very much for choosing our session right now. And today we will be talking about Kubernetes as a scalable foundation for SaaS, software as a service, platforms in the cloud. I am a co-presenter for this session. My name is Sebastian Gemski. I'm a principal solution architect at AWS. But I have the main star of the show here with me. Christian, could you introduce yourself to our audience?
Yeah, hi, my name is Chris. I'm the CTO at a company called Gitpod, and you'll hear a bit more about what it is that we do and how this relates to SaaS in just a moment.
Brilliant, thank you very much. So here's our plan for today, which is very short and straightforward, I hope. We'll talk a little bit about software as a service in general, just to make sure that we are on the very same page when it comes to what kind of challenges do SaaS platforms solve. Then we'll introduce the concept of the cloud development environment, because this is what Gitpod is about. And Gitpod is a great case of a SaaS, which is not that typical, to be honest. Then we'll talk a little bit about how Kubernetes fit in this case, because you may have some intuition about that. And this intuition, I tell you, it's wrong. Then we'll talk about why Gitpod in particular have chosen EKS to host their platform. And in the end, we'll try to summarize some lessons learned so you can come up with something that you can apply in your everyday life, business life as well. Brilliant. Software as a service. Let's synchronize our watches here. So how do you define SaaS? Maybe let's try to avoid the theoretical definition and let's try to work backwards, as we typically do in Amazon, and let's think about what problem is SaaS supposed to be solving, or what kind of challenge is supposed to be addressed with SaaS. So in general, imagine you are a business and you have already some sort of a product, you already have some customers, you already have some clients of yours, and you're growing. This is a good thing, obviously. However, it introduces some problems. It introduces some operational overhead because those clients, they have different pace. They have different posture when it comes to acceptance of the risk and the velocity of change. So you need to adapt somehow when you are offering them various versions, when you are operating those versions for them. If you want it to scale in a proper way, so if you don't want your operational costs to skyrocket, you need to somehow turn your product into some sort of a platform when these operations scale in a way beneficial for you and for your business. Some do, unfortunately, some overgeneralizations when it comes to what it means in practice. Here we have some examples. So some could say that SaaS is just about having a ton of resources somewhere, for instance, in the cloud, and reusing those resources for all the tenants. So that's not what the SaaS is. Some say that if we have automated onboarding of our new tenant, our new client, this is SaaS. That's not the correct answer either, because this doesn't solve all the problems we have. Some do say that just offering software in internet when you can get built automatically is SaaS. So still, this is just the part of the equation. And some would say, which is also obviously not correct, that SaaS just means having separate databases for your tenants, so the data is separated. That's far from the truth. So if I had to provide one single definition of what does it mean to create SaaS, is to turn the product into a service. So which means that to completely remove the operational burdens of onboarding the tenant, creating integrations which are necessary to run this tenant, completely removing that from the view of your client and just providing them an ability to use the features they are interested in. What does it typically mean? It typically means that, of course, yes, there is some functionality that you are providing, but you're adding all of those blue parts. So the usual suspects of SaaS. So functionalities that have to be there, you may call them generic, but in fact, they are, of course, tailored to your particular solution. So what we are saying about onboarding, definitely. Integration with your identity provider, of course. Some metrics and analytics for the sake of billing, and not only, yes, of course. So these are the parts which have to be implemented in pretty much every SaaS business. And in practice, what it really means when it comes to the architecture of the SaaS platforms, it means that we split the functionality of a SaaS platform into two parts. We call them planes. So we have the control plane, which is basically, let me simplify a little bit, everything but the features, everything but the functionality the client is interested in. So this is actually where you deploy the tenant management, tenant onboarding, and so on. And it's separate to the actual application plane. Application plane is where the features reside. So this is the overall, let's say, conceptual perspective of the architecture of the SaaS platform. But still, it doesn't mean that we've just answered all the questions that you're facing when you design your SaaS platform. Because if you made your design decisions, if you create such platform, you need to decide how to organize your data, how to partition the data, how to make sure that the people or the users of the actual client have access only to what they should have access to. How to isolate the tenant. Isolation doesn't mean just the isolation of the data, but also means isolation of processing, so problems like noisy neighbor and so on. This also really depends on the case. This really depends on the functionality of your platform. The identity, this is something I've already mentioned. So how to integrate the identity in your SaaS platform with the identity you already have in your organization. And so on, so on, so on. There are plenty of topics that impact the actual design, the actual architecture of your platform. And funny thing is that if you think about those concerns to be addressed, about these parts of designs to be addressed, for me, it does rings a bell, and it really reminds Kubernetes. It doesn't mean that the only single thing I think about is Kubernetes, no, because you see many of those concerns also present in the Kubernetes space. Multi-tenancy by design, ability to add custom resources and operators, so custom abstractions on the top of the abstractions that are already there. Extensibility, of course, and the scaling to meet the demands of newly onboarded tenants on the platform. So what I would say is that probably the Kubernetes makes a lot of sense when it comes to organizing the control plane of your SaaS platform. So that would be my intuition. However, as far as I know, this is not how Gitpod has approached this particular topic. So Christian, why don't you tell us about what you did?
Yeah, thank you. So let's take an example of a SaaS service, in this case, cloud development environments. So let me talk about cloud development environments for a second. Suppose I'm a developer, I'm a designer, I'm working on a team that builds software, and I want to review this particular PR or any PR for that matter. Traditionally, I'd have to go and check out the code, install the dependencies, get my tools ready, possibly a different version of tools, just to be able to try this. And so this poses a high burden and a lot of effort for members of that team. And what cloud development environments do is they reduce that to the click of a button. In this case, it's a click of a Gitpod button, but there are others too. And with that click, all of these things happen, and I'm put into a fully set up development environment that runs in the cloud. And here it's accessible through the browser. This doesn't need to be the browser. It can be VS Code on the desktop, it can be JetBrains, it can be VI in an SSH session, whatever it is that you want to use. So that's cloud development environments in a nutshell. Now, as you can imagine, this is not your typical SaaS. There is a lot of integration surface that needs to come to pass here. We need to integrate with, for example, the SSO providers, with identity providers that you have to provide single sign-on. There is integration with the SCM, which might as well be on-prem, your GitLab installation that runs on-prem or on cloud-prem. A package repository, think Nexus, Artifactory, things that you need to pull configuration from at development time. There is existing on-prem legacy infrastructure. We've seen this used with mainframes literally standing in brick and mortar buildings. And then there is development and production infrastructure, your RDS instances, and other services that you might need to access. And so what Sebastian described earlier is sort of the traditional like before SaaS, is the traditional self-hosted on-prem mode. And Gitpod itself is a Kubernetes application. It is a Kubernetes SaaS, or SaaS built on Kubernetes. So each workspace that we run is essentially a Kubernetes pod and then some. So we did the natural thing and packaged this as a Helm application so that folks could install it on their Kubernetes clusters. And this turned out not to work very well for a number of reasons. First, we gain a lot of self-hosted problems. We gain a lot of the distribution problems of the before SaaS way of delivering software. Specifically, there is a high installation variance. Kubernetes is not just Kubernetes. There are a lot of different choices around a single Kubernetes distribution, even within one ecosystem that one can make. What type of CNI do you use? What type of CSI do you use? What type of CRI do you use? And all of these bring different variants to the system that you're operating. There is a problem with large batch sizes. Traditional software is delivered at regular intervals. Like the adoption of Kubernetes every 6 months is already pretty difficult to swallow, especially for larger operations. Now think you want to release every month, right? So this is unlikely to happen. So you're going to build up larger batch sizes and in turn increase the risk of an installation of an update failing. And this in turn leads to slow version uptake and long product feedback loops. In SaaS, you can iterate really, really fast because you can run experiments, you can improve the product continuously. That is not true in a self-hosted world. There is a slow uptake, there are no feature flags, none of these things exist here. Also, there are operational concerns. There is a higher total cost of ownership just because there's increased support burden. There is CSM folks that need to be paid and that need to be available, support contracts, you name it. The delivery isn't always clear. And then it turns out Kubernetes can be really hard. Depending on how you do it and depending on how it's adopted in the company, what we found is that more often than not, a good time of our support time would be spent on Kubernetes-specific concerns rather than product-specific concerns. On top of gaining self-hosted problems, we lose SaaS benefits in this model. Specifically, the continuous improvement that I already mentioned, where you don't think about a Slack update, like Slack just updates. It just gets better over time. And that's what SaaS does, it gets better over time. And that's also because the product has telemetry embedded. And this is a partnership. As a user of this product, I have an interest of this product becoming better. The only way it can become better if those who built the product understand what needs to improve. So, summing this back up, consuming vendor software should be easy. Specifically, consuming it on Cloud Prem should be easy. And so the thesis that I'm going to put forward here is that there is a new breed of SaaS coming with Kubernetes at its heart. And that is a new breed of hybrid SaaS. And so the way this looks like is we still have our control plane that lives as we've known it. It lives in the cloud environment of the vendor that you're buying that software from. And that might as well look like this. It might look very different. It's also not much of your concern. It is a black box for that matter. The application plane itself, however, lives in your AWS account. It lives on Cloud Prem. And a big benefit of this setup is that it resolves a lot of compliance issues and it resolves a lot of concerns with what that application plane can access in your existing infrastructure. So those two interact not just in the usual way of control plane telling the application plane what to do, but also in a way that the control plane will maintain the application plane itself. And we'll see more details and an example of how this could be implemented in a moment. What I want to bring forward is that this is a model that we're seeing more and more in the wild. APM providers have pioneered this, right? Think your Datadog, your New Relic, your Dynatrace. But also Snowflake, SourceGraph, Databricks, GitLab Dedicated is up and coming, and then of course Gitpod Dedicated, the product that I'm going to talk a bit about here. The promise of this new breed of hybrid software is it's like on-prem, on Cloud Prem, except with the SaaS benefits, and it is SaaS. It is not something that you have to think of in traditional operational terms that an ops team within your organization would install and then need to maintain and operate, it is very much consumed like you would consume a SaaS. There's an SLA for it, there's an uptime SLA, there's a support SLA, and it is not your operational concern. And the key thing here is that at the very heart of that application plane and potentially the control plane is Kubernetes. And the reason is that, as we'll see later, there's a trade specifically between security and operational concerns in this operationally distributed model where Kubernetes really has really favorable features and functionality. At Gitpod, we specifically choose to focus on EKS as Kubernetes platform. And Sebastian will talk a bit about EKS, and then we'll dive into the details as to why we chose it.
Thank you. Amazon loves Kubernetes, and AWS in specific. And there is not much exaggeration in this statement. We are heavily involved in the community and the development of a Kubernetes ecosystem since pretty much the beginning of its public availability. So we can see plenty of projects, community projects that we've contributed to. And needless to say, those projects do not run only on AWS. The majority of them can be applied across any kind of Kubernetes deployment that you want. Also, AWS is a member of the Product Security Committee, which means that we are trying to actively shape the future of the Kubernetes ecosystem as well. But it's not just that we are involved in the open source activities. We also have our own offering. We have a service which is called EKS. It's a managed Kubernetes. And the idea for that service is to provide everyone an option to run Kubernetes in the simplest possible way without the burden of manually installing, configuring, provisioning the Kubernetes clusters on your own. So that's why we've created the service, which is not our version of Kubernetes. This is the vanilla version of Kubernetes, which is enriched with the additions which do not change the essence of Kubernetes being Kubernetes, but which simplifies using EKS, using Kubernetes in AWS by, for instance, simplifying the integration with other services in AWS portfolio. So, for instance, EKS, managed Kubernetes in AWS, in Amazon Cloud, lets you use the benefits of very simple integration with the networking of AWS and with the security of AWS. So you don't have to patch it manually, you don't have to reinvent the wheel, you don't have to create this on your own. You can use what is already provided within EKS. The same applies to storage. So you can use the services which are already present, which you have probably already used, which you are familiar with, and integrate them with EKS in a very simple way. And the category which really, I would say, deserves a special treatment is the actual compute resources where you can deploy your EKS clusters on. Because you have like a huge flexibility here. You can, of course, use self-managed node groups if you want to provision those nodes on your own. Or you can use managed node groups, or you can even use our serverless compute plane AWS Fargate, which means that in this case you are just running Kubernetes on the serverless compute fabric, which is something that, even if it sounds a little bit contradictory, is reality. Yeah, so when it comes to other advantages of EKS, I've already mentioned networking capabilities, but that's not all. We are heavily integrating with projects like, for instance, OpenTelemetry to make sure that we create the connectors that let you integrate with pretty much any telemetry tools of your choice with EKS clusters without the need to creating, for instance, data exporters. This is done pretty much for you. So there are plenty of metrics which are provided by AWS services. If you deploy them on EKS cluster, you have that pretty much on your own without much work on your side. Of course, you can use any AWS load balancing service that is available right now with the EKS cluster. And again, you don't have to patch it manually. This is done by us within AWS. And also, we provide you a lot of development tools that you can use for EKS. There are sorry for that. There are EKS blueprints, there are ACKs, and we have also a special flavor of our CDK, which is called CDK 8S, which you can use to create infrastructure as code specifically for your Kubernetes, so you can decide how to structure your cluster, what to deploy there, using your favorite language, programming language of your choice, just like in case of CDK. So you don't have to do that in YAML. You can, for instance, do that in Python or in Ruby or in JavaScript, and you can add your own extensions in this favorite programming language of your choice, which is pretty much the probably most favorite way to complete such tasks by developers. There are also plenty of compliance standards that we are compliant with. I'm not going to read all of them. I'm not going to pretend I know all of them by heart. And of course, we also support all the majority of popular open source projects like KubeCost or Kyverno. That is also supported on EKS. And Christian, why did Gitpod decide to choose EKS in particular?
Yeah. One key feature that really matters to us is the ability to bring custom AMIs. It's the ability to have a managed Kubernetes service and yet have full control over the nodes on which those workloads run. And that's really, I want to say, a unique feature in the land of managed Kubernetes distributions. We really care for this degree of vertical integration just because of the functionality that Gitpod offers and the need to integrate with really new versions of the kernel and integrate deeply with what we do. IRSA is a big one, so the ability to have Kubernetes workloads connected to the Amazon ecosystem without the need to shovel service accounts around, without all the complexity and compliance nightmare that this brings. We forgot to encrypt something in Git, and now we have it, need to rotate everything, and all of that jazz just goes away entirely. So configuration becomes considerably simpler this way. The network integration, also really interesting, specifically VPC CNI, meaning that each and every single pod that you run gets an IP from your VPC. And so you don't need to do any sort of NAT trickery just to get into that network. And that enables a whole new range of applications. For example, WebRTC doesn't play nice with double NAT. And these kind of problems we just avoid by using this type of technology. The load balancer integration that Sebastian alluded to is super simple to use. It's a set of annotations, and away you go. So let's talk about that hybrid breed of SaaS, and we'll come to the EKS side in a second. How does this work? So say you want to consume the SaaS, what do? Well, you sign up for it, you get a CloudFormation template, you apply that to your own account, and so far it looks an awful lot like, yeah, this is kind of like self-hosted, except that from that moment on, the infrastructure that gets created by that CloudFormation template registers itself on the control plane, on the Gitpod control plane, and gets maintained and operated by that control plane from that moment on. And so there is really a hybrid sort of operational model at play here, where the application updates and security updates and all of these remediations and case of outages or service interruptions happen automatically through the control plane of the SaaS, and the only thing that's up to the customers is to maintain the core basic infrastructure, which basically means applying a CloudFormation template every once in a while to the tune of months, right? The key thing is that the operational concern, the operational burden of this solution is entirely on the software vendor. There is no ops team that's needed within the organization to consume a service like this, as you would expect from SaaS. You're not buying Slack and expect to have a 5-people ops team running Slack in your company. So how do we build this? How does this work? And so specifically, the application plane is really interesting here. And in this application plane, what we do is we use a set of Lambdas, and you might know be going like, wait, this is a Kubernetes talk, why are you talking about Lambdas? We're using a set of Lambdas to operate Kubernetes. And the motivation for this is simple. Lambdas are very easy to deploy and operate they're very hard to fail, and they require little or less observance. Initially, we thought to run a separate Kubernetes cluster alongside, but then you have a bit of a chicken and egg problem. And so what these Lambdas do is they basically feed out of a spec definition that is stored in DynamoDB, and then operate the Kubernetes clusters according to this spec. And this will be very familiar to you. This is essentially how a Kubernetes controller works, right? And so this is the exact same pattern, except lifted to Lambdas. And so any change to, for example, AMIs, but also the application that runs on this, any kind of any kind of YAML that needs to be applied to this, any application update, is administered through the Lambdas. And so you might be wondering, all right, why do it this way? This seems convoluted. Why not just assume a role in the target account and do it this way? Like, why have some of what's essentially the control plane delegated into the application plane? And the reason for that is that there is a trade to be made here between essentially security compliance and the access that a software vendor gets into your infrastructure. So clearly, the more access there is, the more operational ability there is. You all know this. If you're admin in an account, you can do everything. You can also shoot yourself in the foot really easily, but it becomes easier, quote unquote, to operate something. At the same time, though, that's also a security nightmare. Right? The more access you have, the more chances there is for something to be compromised in a way. And so especially when you have this sort of hybrid relationship where there is one entity operating software for someone else, as in SaaS, that is the case, you have this trade that needs to be made more fine-grained than it would be in a sort of traditional all within one organization setting. So there is a sweet spot here where there's enough operational capability so that the SaaS vendor can uphold SLAs and the compliance and security team of a consuming company can sleep at night. And it's exactly that Lambda trade that lets us do this. Now, one key bit in this integration is how do you access the services that are provided from the application plane. And a simple way is if the application plane just offers one service that you can access, say a web service of some sort, then private link is a really good choice. If, however, there is more of a bidirectional connection, as is the case for Gitpod, for example, where the application plane needs to access existing infrastructure plentyfold, Transit Gateway is a better choice. And the reason is primarily an operational one. You set up the routing once, and you don't have to go through all the trouble of the organizational trouble, not technical trouble, I want to highlight that, of setting up private link. Now, if you do that, you're going to run into issues like, hey, we have some SIDA overlaps here. We're already using that range. One good way to solve that is to use a really obscure SIDA range like the CNAT SIDA range. So you're all going to go out now, use the CNAT SIDA range, and when we come to talk to you, we're going to go like, yeah, we heard your talk. We're using that range now. All right, summing this up. There's a new breed of hybrid SaaS coming with Kubernetes at the core, where Kubernetes provides the application plane that provides the actual value providing service itself. And the reason we use Kubernetes is for all the reasons that Sebastian pointed out. That is the per tenant runtime. So one way to sort out the tenancy isolation is by having essentially an EKS installation per tenant. That's one way of doing it. And lastly, Kubernetes, specifically EKS and Lambdas, play really well together. It's a really nice combination, not only in the hybrid SaaS model. And with that, thank you very much for your attention, and we'd be very happy to take any questions either right now. We'll also be around after this conversation, so come and find us or ask in this forum. Thank you very much.
Thank you.